My team is conformed by Alondra Lopez, Andrea Herrero, Carla Aragon, and me, Sofía Ravelo. Cool, let's start. The first problem says that you have two charges. First, the Q1 and Q2 that are separated by 15 centimeters in the air. First, we need to order our data. So we have K, that is 9 by 10 to the 9 newtons by square meters divided by square coulombs. Then we have Q1, that is minus 9 by 10 to the minus 6 coulombs, and Q2, minus 5 by 10 to the minus 6 coulombs. Then we have R, that is 15 centimeters, and we change it to the meters, that is 0.15 meters. Okay, so the problem says that we need to get force. The formula we need is K by Q1 by Q2 divided by square R. So we need to multiply 9 by 10 to the 9 by 9 by 10 to the minus 6 by 5 by 10 to the 6. So then we have the multiplication. We're going to divide that number by 0.0225 square meters. And then we have just to cancel coulombs and square meters, and we have newtons. So the result of this multiplication and division is minus 18 newtons. But we need to change it to 18 newtons. The answer of the first question is attractive. Why? Because opposites attract. So the second problem says, calculate the magnitude of the electric field at the distance of 30 millimeters from a charge of minus 10 by 10 to the 6 coulombs. The first thing we need to do is to convert the millimeters to meters. So we divide the 30 by 1000, and the result of it is 0.030 that we multiply by it, because in the formula says that we need square R. So the answer is 0.0009 square meters. We can continue with the formula. The formula says that we need to multiply K by Q divided by square R. So we multiply 9 by 10 to the 9 by minus 10 by 10 to the minus 6, and the result we're going to divide it by 0.0009 square meters. We get 1.00 by 10 to the 8. And now we just have to cancel the units. So we have 1.00 by 10 to the 8 newtons divided by coulombs. And that's the answer to problem number 2. Okay, now we have the third and the last problem, but it is huge. So I recommend you to sit, take some popcorn, and look at this. Okay, so the third problem says 3-point charges Q1, Q2, and Q3 are placed on the corners of an equilateral triangle with sides of length of 80 millimeters. Find the magnitude and direction of the net force over charge Q1, that is equal to 7 by 10 to the minus 6 coulombs. Okay, first we have the data. We have Q1, Q2, and Q3. Q1 is 7 by 10 to the minus 6 coulombs, Q2 is minus 7 by 10 to the minus 6 coulombs, and Q3 is equal to 3 by 10 to the minus 6 coulombs. And then in the triangle, we have the length that is equal to R, that is 80 millimeters, that we need to convert it to meters. So we divide it by 1000, and it's equal to 0.08 meters. K is equal to 9 by 10 to the 9 newtons by square meters divided by square coulombs. So the only thing that we need to get is net force. So let's start. In the first step, we need to get force 2 to 1 and 3 to 1. So first we're going to get 2 to 1. The formula is K by Q2 by Q1, and that result we are going to divide it by square R. And that's the result of F to 2 to 1. And it's equal to, so the answer is 68.90 newtons. And then to get F to 3 to 1, we're going to multiply 9 by 10 to the 9 by 3 by 10 to the minus 6 and by 7 by 10 to the minus 6. We cancel the units, and the result we are going to divide by 0.0064, and the result is 29.53 newtons. And the second step, we're going to get the x and the y of f to the 2 to the 1 and f to the 3 to the 1. So we know that we have an angle in each side of the triangle of 60. So we're going to take that to make the formula. So now that we know that, we're going to take the values of 2 to 1, that is 68.90, and we're going to multiply by cos of 60, and that's going to be our result of f to 2 to the 1 x. And then to find 2 to the 1 y, we're going to multiply the same 68.90 by sine of 16. Then we're going to make the same with the value of f3 from 3 to the 1. Now that we get x and y of each force, we're going to sum it with each value. We're going to add the values of 2 to the 1 of x and 3 to the 1 x, and we're going to add the values of y of 2 to 1 and 3 to 1. Now we can get the formula of net force. So we're going to make like this. We're going to put the square root, and then we're going to put 19.69 square plus 85.23 square. And that result, we're going to put the square root, and the result of it, that is 87.46 newtons, it's the net force. And the last thing we need to do is to get tangent. How we get tangent? So easy. You just need to divide fx by fy, and that's all.